Hey, welcome. I wanna thank everybody who's watching this video, and let's go ahead and start with what we call a sequence. So starting with the sequences is collection of things in order. So basically we can say a sequence has a first term, second term, and third term, and so on. Normally we represent sequence by the following: A1, A2, AN. So this is basically the terms of the sequence. A1 being the first term, A2 being the second term, A3 the third term, and so on. And of course, sequence can be said is a function whose domain is the positive integers. Another way, the domain of the sequence are the subscripts of each element. So that would be the 1, the 2, the n, and so on. So given any sequence can be represented by its nth term. For example, we can say an equal, say, 2n plus 1. So this is a representation of that sequence. To go ahead and determine the element of the sequence, then we can say A1, another way, the first term of the sequence is equal to, we're going to replace n by whatever subscripts A has. In this case, 2 times 1 plus 1. So that's equal to 2 plus 1, which is 3. So the first element of the sequence, or the first term of the sequence, is 3. The second term of the sequence, A2, is, now we replace m by 2. So it'll be 2 times 2 plus 1, which is equal to 5. And then A3, again, 2 times 3 plus 1, which is equal to 7, and so on. So basically, this is how we find the element of each sequence. We take the nth term of the given sequence, and then we replace whatever n is in in the nth term. So that will give me that particular term of the sequence. So second, we have two types of sequences. One is called a finite sequence. A finite sequence is a sequence whose number of terms is known. For example, we have, say, A1, A2, A3 to AN. So notice that after AN, I didn't put any dots in there, so that's an indication that this sequence terminates. And wherever n is, this is your last term. So if n is 1,000, we can have 1,000 A1 all the way to A1000. So this is basically a finite sequence. Or n could be trillions or what have you. As long as we have a number for n, so this is going to be a finite sequence. And then we have an indefinite sequence or infinite sequence where we have represented in the following manner. Say A1, A2, A3, AN, and after AN, it continues on for the next term and so on and so on. Notice after AN comes AN plus 1, and it continues. So it doesn't really terminate at AN, it continues on forever and ever for as long as we can. As long as there is a number, we have to do it. So these are basically the principles of what sequences are. So we have so many types of sequences. So first, I'm going to look at some of the ones that they have in the book and explain a little bit about them. Okay. So consider the following sequence. It says, say n equal 3 minus -1 to the power. And in this particular case, find the first 5 terms. Finding the first 5 terms of the sequence is again is simple. We're looking for A1, A2, A3, A4, and A5. To find the terms of the sequence, again, we're going to take the nth term, which is given, and every time we see n in that equation, we're going to replace it by whatever number I'm looking for. So in this case, I'm looking for A1, so I'm going to take that equation, 3 minus -1 to the power 1. So that is equal to 3 minus -1, which is equal to 4. Of course, double negative makes positive in this case, so we end up with 4. For the second one, we have 3 minus -1 squared, which is equal to 3 minus +1. So in this case, because -1 squared is a positive 1, so in this case, we're going to subtract, and that's going to give me a 2. And then, of course, we have when a is equal to 3, n equal to 3, so it'll be 3 minus -1 cubed is equal to 3 minus -1, which is equal to 4. So notice in this particular sequence, we do have the elements of the sequence are 4, 2, 4, and of course, the next one is going to be 2, and so on. Notice the only thing that changes the -1 when the n is even. So we're subtracting 1 from 3, and when n is odd, we're adding 1 to 3. So that's all we're doing in this particular sequence. So we're just simply either adding 1, subtracting 1 at that time. So of course, A4 is 2, A5 is going to be 4. So this is basically those sequences in this sense. So I'm going to pause for 1 second, as long as I can see where the pause is. Here it is. In this particular sequence, this sequence is called recursive sequence. The reason we call it recursive sequence is because every term depends on the terms before it. Notice how this sequence is given. We are given the first term to be 3, and any other term we're looking for, then we have to use the previous term and add 2 to it. Okay. So this is called recursive sequence. In this particular questions, we are looking for the first 3 terms of the sequence. Another way, we're looking for A1, A2, A3. In this particular sequence, since it's a recursive sequence, then A1 is given as 3. A2, according to the formula for the k terms, so it has to be A2 minus 1 plus 2. That's equal to, now notice the 2 minus 1 is a subscript. So to figure out which term we're looking at, we need to evaluate those 2 numbers. So if I take 2 and take away 1, that's going to give me A1 plus 2, so that is equal to, now A1 we know it is 3, so that's a 3 plus 2, and that's equal to 5. So this is the second term of the sequence. So now for the third term, we have A3 equal, we use again the formula, we replace K by 3. So that'll be 3 minus 1 plus 2, which is equal to A2 plus 2, which is equal to, now A2, we already found it is 5. So 5 plus 2, which is 7. So this is basically the third term of the sequence, which is 7. Now, if I wanted to go A4, it would be A3, which is 7 plus 2. In this case, that's going to be 7 plus 2, which is 9. So A4 is going to equal to 9. One of the sequences that is famous for in this form is called Fibonacci sequence. So let's go ahead and write that down. And the Fibonacci sequence is, let me just see the spelling, called the Fibonacci sequence. Fibonacci sequence is a sequence in which the first two terms are given. So basically, A1, say in this case, equal to 1, A2 equal to 1. So in both cases, we're given A1 and A2. And then AK equal A, K minus, sorry about that, K minus 2 plus A, K minus 1. So another way to find the third, and for K equal greater or equal to 3. So in order to figure out what A3 is, so A3 would be A 3 minus 2 plus A 3 minus 1, which is A1 plus A2. And in this case, we are given the first two terms of the sequence. It's going to be 1 plus 1, which is equal to 2. Now, if I'm interested in A4, so that's going to be A4 minus 2 plus A4 minus 1, which is A2 plus A3, which is going to give me, in this case, A2, we already know it is 2 plus 1, which is 3. So in order to figure out the next term of the Fibonacci sequence, you have to know the two terms before. So the sequence is, first term is 1, then 1. When I add these two, I get a 2. I add these two, I get 3. I add these two, I get 5. I add these two, I get 8, and so on. So basically, this is what's called the famous Fibonacci sequence, where each term in the sequence after 3 and above depends on the previous two terms of that particular sequence. So now we talked about few sequences. Given a sequence, how do I find the nth term of that particular sequence? So let's go ahead and write a sequence. Okay. Let's take one from the book itself and pick says to write expression for the following sequence. I'm going to take an easy one first. So 1, 5, 9, 13, and so on. So the question is, so we're trying to figure out the nth term of each particular sequence. So this is a 9. Okay. So one way of looking at the sequence, if you want for ease, just take every two numbers, consecutive two numbers, and subtract them and see what you get. So if I take 5 and subtract 1 from it, I get a 4. 9 minus 1 is minus 5 is 4. 13 minus 9 is 4. So that is an easy sequence. This particular sequence is kind of linear equation, if you want. So the sequence starts as, so we know then AN is, we have 4 n. This is to start with. Now, of course, we still have numbers here. We haven't finished it. So let's figure out what else we need to do. So how do I figure out what's left? So now I'm going to take my first sequence, 1, 5, 9, 13, and I'm going to put whatever 4n is. So when n is 1, so I'm going to take the first 4 terms. N is 1, so we have a 4. N is 2, then we have 8. And then when n is 3, we have 12. And then when n is 4, we have 16. Again, I'm going to go ahead and subtract these two. So 1 minus 4 is negative 3, negative 3, negative 3, and negative 3. So now we know after I say 4n, since this is all the same, then the next step is an would be 4n minus 3. So basically, this particular sequence has an nth term of an equal 4n minus 3. How do I check that? Well, let's see what a1 would be. If I put 1 for n, so 4 times 1 is 1, minus 3 is 1. That's the first term. If n is 2, 4 times 2 is 8. 8 minus 3 is 5. That's your second term. And then 4 times 3 is 12. 12 minus 3 is 9. And that's the third term. And A4 would be 16 minus 3 is 13. And this is basically the sequence represented by an nth term. So now, if it is linear, then usually we're going to start finding the repetition right away. What happened is not linear. Let's take another one. Maybe it's not linear. So let's start with, say for example, the following sequence. First number is 1. And then, let's say 5. Oh no, the first one, so let's make that a 2, I'm sorry. So this is 2, and then we have a 10, and let's say 17, and let's say 26. So let's say this is the sequence that we have, and we need to figure out what's the nth term of this particular sequence. So what I'm going to do is, again, we're going to start with subtracting those two numbers. Every two consecutive number, subtract them from each other. So we have a 5 minus 2 is 3. 10 minus 5 is 7. And then, 5. I need to check my math again. 17 take away 10 is 7. 26 take away 17 is 9. So now we have the following after doing the first subtraction. But in this case, they are not the same. So if they're not the same, I need to do one more subtraction. So let's do again. So 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So notice I had to do 2 subtractions to get those numbers to be equal to each other. So that means this is first subtraction will be n to the first, the second subtraction will be n squared. So that means because the second subtraction was the same, so this sequence has n squared term. So how many n squared to determine that? You take whatever number you got, you divide it by 2. So divide by 2, you get 1. So that's going to be 1n squared. So the sequence has an equal n squared. So this is the start. We haven't finished. We need to figure out what the rest of the sequence is going to be. So let's go back to the original sequence, which is 2, 5, 10, 17, 26. And let's write underneath it n squared. For n equal 1, n squared is 1. For n equal 2, n squared is 4. For n equal 3, n squared is 9. For n equal 4, n squared is 16. And then for n equal 5, n squared is 25. So doing this, we're going to go ahead and subtract. So 2 take away 1 is 1. 5 minus 4 is 1. 10 minus 9 is 1. 17 minus 16 is 1. And then 1. So we can see that all of these numbers happen to be 1. So that means this number is really added to the n squared we have. So an would be n squared plus 1. So this is the sequence, the nth term of the sequence that is represented by these two numbers, by these numbers. So if I want to check it again, 1 squared is 1, plus 1 is 2, that's the first one. 2 squared is 4, 4 plus 1 is 5. And 3 squared, 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. And 5 squared is 25, plus 1 is 26. So this is how we can find the nth term of a polynomial sequence. Now, if I have to go 3 times, then we're talking about n cubed. And notice for the n squared, we divided everything by 2. For n cubed, you divide by 6, which is 2 times 3. So n4, you're going to divide by 24, which is 2 times 3 times 4, and so on. Hopefully, as you practice on the first linear and quadratic, you will start figuring out the rest on your own by doing some practice in that sense. So now we're going to look at the definition of factorial. First of all, the symbol of factorial is the exclamation mark. So this is factorial. What does it mean to say factorial? So if I say n factorial, where n is positive integer, then this is equal to 1 times, 2 times, 3 times, 4 times, all the way to n. So another way of saying it is n factorial means the product of n by every number below it until you get to 1. So example, 5 factorial is 5 times 4 times 3 times 2 times 1. And that will give me 5 factorial. Now, using your calculator to figure out the factorial, then first you write the number 5, and then you press the key math, and then you go to the probability, and then under the probability, you should find the term factorial. So if I do that, that's going to be 20, 60, 120. So 5 factorial is equal to 120. So if you learn how to do that in the calculator, that will also help you a whole lot in doing some of the problems that you're looking at. Also note, since 5 factorial is equal to all of this, we can also rewrite this as, since 4 times 3 times 2 times 1 is 4 factorial, so this also can be written as 5 times 4 factorial. Or we can write it as 5 times 4 times 3 factorial. So if we don't have a reason to write all the numbers down, then we can go ahead and write it as 5 times 4 times, we continue until the number we want, and then we can say factorial. For example, this is helpful when you're doing simplification of fraction. Suppose, for example, we need to simplify 100 factorial divided by 98 factorial. So this means I'm going to have to write the numbers 100, 99, 98, 97, all the way to 1 in order to figure out what that is. I can also write it as, since I needed 98 factorial and 98 is less than 100, I can say this is 100 times 99 times 98 factorial. Notice I stopped at 98, then that number is going to be factorial divided by 98 factorial. So now we can go ahead and simplify these two numbers, and that's going to give me 100 times 99, which is 9900. Now sometimes we have to use that because sometimes it's not easy to write 100 factorial on the calculator. It probably doesn't have enough spaces in there to give you that number. So this way you have to use these particular symbols. Now, two definitions about factorial is 1 factorial equal 1, 0 factorial equal 1. Both of these are equal to 1. So those are by definition. So you have to take those as is. And by definition, this is what they are. Okay? Let's go ahead and do a couple of examples of factorial and see what we can do with that. So let me erase this. So we have 8 factorial divided by 2 factorial times 6 factorial. How do I simplify this without the use of a calculator? Well, simply now, notice we have 8 factorial on top, we have 2 factorial, we have 6 factorial. And by the way, that does not equal to 12 factorial. You can figure that out by yourself in there and see how it goes. Since the top number is the bigger number, I'm going to go ahead and expand that. Now, I don't have to expand it all the way. I'm just going to expand as much as I need. So I need to go down to 6 because we have a 6 down here. So I can say this is 8 times 7 times 6 factorial. Now notice, I can go down to 2 if I wanted to, but what's the purpose? This is 6, I need to get rid of the bigger number, not the smaller number. Now on the bottom, 2 factorial is simply 2 times 1, which is 2 times 6 factorial. So now we can see that those 2 factorial 6 cancel out. So that's going to give me 8 times 7. Divide that by 2, which is 56 over 2, or simply 28. So this is basically how we use simplification of factorial without using the calculation. Okay. Another notation we're going to look at today, and this is called summation notation. Summation notation, for example, consider this is the symbol. This symbol is called sum. This symbol is adding whatever in here from whatever number to whatever number. For example, let's say I equal 1 to n, ai. So what does that mean? That means we're going to look at, first we're going to replace I by 1. It's going to be a1 plus, then I equal to a2 plus a3 plus all the way to an. So I can say, for example, summation I equal 1 to 5 ai. This is a1 plus a2 plus a3 plus a4 plus a5. So we're going to add all of these numbers together of a particular sequence if given. So we'll go ahead and add its numbers. Or we could say summation I equal 5 to 8 of ai. Now again, here I doesn't start at 1. It starts at 5. So I'm going to start that at 5. So it's going to be a5 plus a6 plus a7 plus a8. a8 is the last number, so I will stop at a8. And this is basically how we write the summation. Now let's figure out how do I write the summation of particular expression. So starting with any expression, let's go ahead and do that. Say, for example, I'm looking at the sum of 2i plus 1, I equal 2, 2i equal 4. So that means I need to figure out what number do I get here if I replace I by 2, replace I by 3, replace I by 4. And after that, I want to add all of these terms up. So let's write them one by one. And I'm going to write over here, I, and then we have, if when I is 2, which is the first term becomes 2 times 2 plus 1 plus. Now I'm going to put I equal 3. So it's going to be 2 times 3 plus 1. Then I'm going to put I equal 4 plus 2 times 4 plus 1. So now this is going to give me 4 plus 1 is 5, plus 6 plus 1 is 7, plus 8 plus 1 is 9, and that's going to equal to 21. So if I add those three terms, I get 21. So the sum of this is equal now to 21. So when you're doing the summation, this tells you the limits from where to where, and over here it gives you the formula you have to use for each term in that summation. Any questions? All right. rules or properties of summation. Let's take simple rules. For example, let's say I'm looking at summation I equal 1 to 10 of some constant C. Some constant C, that means it's a number that has nothing to do with I. No matter what I is, this is always going to be C. So when I equal 1, this is C. So the first term is C plus the second term is C plus C plus C plus plus C. How many times we have to do that? We're going from 1 to 10, so we have to do that 10 times. So this is equal to 10 times C. So if you have a constant here, so if you have a 1, so that'll be 10 times 1 will give me 10. If you have a 5, 10 times 5, which is 50, and so on. So you need to figure out how many numbers you have. So first property is summation from I equal 1 to n of some number C is equal to nc. So n is the number of terms that we're getting counting from 1 to n. So remember, if I doesn't start at 1, so it's going to be whatever it starts from. So let's say it starts at 3. If it starts at 3, then we have 2 less terms. So it'll be n minus 2 times C and so on, depending on how many terms you have in each particular equation. So if we have, for example, summation I equal 1 to some number, I just say n, of some number times ai. Well, what's that equal to? So that's equal, if I put 1 for I, it's going to be C A1 plus C A2 plus C A3 plus C A n. So no matter how many terms you have, you're going to end up with that. Now notice all the terms have C in them. So that's equal to C times A1 plus A2 plus A3 plus AN. So this is equal to C. And we just said before, all of these added together is just simply summation I equal 1 to n of AI. So really, if I have a constant multiplied by some variable in here that depends on I can put the constant out and then say summation I equal 1 n of CA I equals C summation I equal 1 to n AI. So I really don't have to add the C at the end of the day. I can just simply multiply that C by that number. Suppose we have another property is we have some kind of sequence. Suppose we have summation I equal 1 to n A I plus B I. So in this particular case, we have 2 different sequences in there, and each one depends on what I is. If I rewrite that, so that's going to equal to A1 plus B1 when I equal 1 plus A2 plus B2 when I equal 2 plus all the way to AN plus BN. So now notice we do have A1, since we have addition throughout, A1 plus A2 plus A3 plus AN. So I'm going to put all the A's together. That'll be A1 plus A2 plus AN. Plus, we're going to put all the B's together. B1 plus B2 plus Bn. So now we can see that this is nothing more than summation I equal 1 to n of AI plus summation I equal 1 to n of bi. So if I do have an addition inside the sum, I can really split those sum into two parts and get a new property says summation I equal 1 to n of AI plus bi equal summation I equal 1 to n AI plus summation I equal 1 to n of. So this is another one of those properties that we could use for summation. Last property. Now notice if I do put a minus here, all the bn's would be minus. So instead of a plus, so it's going to be minus. So this property works with a positive and also with a negative. So if you have AI minus bi, you will get summation of AI minus summation of bi, and therefore this is the particular numbers for those.